So this talk will be a change of pace from the previous two talks. It's enhancing query execution visibility in OpenSearch with OpenTelemetry. I know that's a huge, large title, but let's break that down. So we'll start with covering observability. We'll continue to talk about OpenTelemetry, go into the architecture of OpenTelemetry, and talk about how we use OpenTelemetry in OpenSearch. Hopefully, after this talk, you will be able to use OpenTelemetry to achieve observability in your own service. So what is observability? Anyone from the audience in a simple term? Any volunteers?
Knowing what's going on with your compute.
Yeah, in a way, we can. So, oops. Sorry about that. Yeah, so building on what my friend said here, so it's understanding the internal state of a software system by examining its outputs. It's really helpful in troubleshooting a system and essentially answering the question, why is this happening? So what are these outputs that we can get that can be helpful? So why do we need observability? As mentioned, for troubleshooting, debugging, really helpful to monitor the performance of a system, incident management for systems where you have an external customer. So systems nowadays are becoming so large, with a lot of frameworks and libraries and other aspects. It's hard to understand a system just by reading the code. So it really helps improve the system understanding by seeing these observability dashboards. It helps with scalability, security, and many other aspects. So how do we achieve observability? So we achieve it using instrumentation. It's basically the process of adding code to a software service that emits signals to understand its inner workings. So what are these signals that we can emit from our software systems? So metrics, logs, traces. So these are the three pillars of observability. Okay, perfect. Yeah, so as I was saying, these are the three pillars of observability. These are the signals we can emit from our software services to better understand the system. Metrics are essentially numerical values that show how well a system is doing over time. They can be of the form of counters or gauges. So some examples of metrics that most of you all might have seen are CPU usage, network latency, number of users, and so on. Metrics usually translate to sleek dashboards and visualizations and are often the first call to developers to understand what is happening in a software system. Metrics can have various attributes or dimensions. So consider the example of the metric of name requests. We get the count of the requests over time as seen on the left. If we add an attribute called status code, it adds a layer of information on top of this metric. So we can see charts for the number of 2xx, 4xx, 5xx requests, and so on. One thing to note here is we need to watch out for cardinality explosion. So let's say if the number of possibilities of values of the status code or a metric is very large, this can cause a lot of issues when storing and retrieving from time series databases. So really watch out for that one. A log is a timestamped message emitted by services or other components. I'm sure most of you all are familiar. In general, developers spend a lot of time looking at logs, and they're ubiquitous because of their ease of use. So this page should be familiar to everyone here, hopefully, but log can also have various attributes such as level, message, timestamp, and so on. Coming up to the interesting pillar, distributed tracing is the third pillar of observability. It's basically a method of observing requests as they move through a distributed system. So nowadays, distributed systems follow a request-response model, where a request comes in, it can go through multiple microservices, perhaps hit a database, and then go back to the client. So distributed tracing manages the life cycle of the request and helps us track the request. You can think of it as a set of logs and attributes and metrics, all correlated with a shared ID. So more on that later. The two components of distributed tracing is traces and spans. A trace, you can imagine, it's kind of a detailed map of a user's request or journey across various services. And spans are the individual unit of work, like a trace can form multiple spans. Let's think of an analogy to understand this. Who here has ever gone on a road trip in their life? Show of hands. I'm hoping everyone here. Okay. So think of a road trip from, let's say, Berlin to Munich. And you start and you have multiple stops in the way. Let's say you stop for gas or shopping, a restaurant possibly. So the entire road trip can be thought of as a trace. And the individual stops are spans. Spans can have various attributes, such as the name of the place you stop at or the duration of the stop. So similarly, in a distributed environment or distributed service, consider the following example of a payment application. We have a client that's sending in a payment request. The payment request hits a public API, and it can possibly go through authentication service, display, multiple microservices. The payment service, in turn, might call a couple of DBs in the backend. On the right side, we see the payment request is the actual trace, which is tracking the life cycle of the request. Each blue box underneath the request is a span. Spans follow a parent-child relationship, where the payment span, for example, have two child spans, DB and query. How that works is when a request comes in, we have a trace ID that's unique across the request, across the lifecycle of a request, and it provides context to the metrics, logs, and anything that's generated along the way. Each unit of work, for example, a database or a separate service, can create a new span, which has a new span ID to track this. As mentioned, spans can store various attributes. A very useful one is latency. It's really helpful to debug the performance of a system. So let's say our average latency for a database span is showing up as very high, or for a particular request, we see that the database is problematic. This is really helpful to find performance bottlenecks in the system. Quickly, here is a parent span example. We have a trace ID, span ID, and various attributes. And the child span, which has the parent ID associated with it. And as mentioned, tracing is really helpful in evaluating the performance of a system, and it adds context, connecting your logs, metrics, and all of it together. So given all of that, what is OpenTelemetry? Open comes from open source, and tele meaning remote measurements. So in a simple sentence, it's an open source technologies allowing to collect remote measurements. But what it really is an observability framework and toolkit designed to instrument, generate, collect, and export telemetry data such as metrics, logs, traces. So a telemetry pipeline at a very high level can look as follows. On the left, you have your app or service that you want to instrument. We have the OpenTelemetry APIs and SDKs used to instrument the service. We have a kind of mini processing pipeline within the service itself that OpenTelemetry provides, where you can aggregate the data, decorate it, possibly add some, for example, add a node ID to the log or something like that. And finally, they provide us with exporters to export this data to various services. OpenTelemetry also provides a collector where you can export this data that collects, aggregates, and finally exports this to a telemetry backend. Don't worry, all this will make sense in a minute. So just to recap a bit, we have your telemetry data, tracing, metrics, logs, all connected by a context. OpenTelemetry has its proprietary protocol that can send this to the OTel collector. And we can use various protocols to send it to, hopefully, OpenSearch or some other open source technology. So OpenTelemetry provides us with the instrumentation libraries, the APIs and specifications, the exporter collector as mentioned. It's compatible with various backends. It gives us all the goodies like the documentation, best practice, community support, and so on. The architecture is really interesting. And let's start with your service that you want to instrument. So the box is showing your service. You need to import the OTel API and SDK. The business logic in your service, the frameworks, clients, database, etc., everything will use the OTel API to instrument or generate signals such as metrics, logs, traces. The OTel SDK will then process these requests and finally export it to your telemetry pipeline. So in general, what happens if you make an OpenTelemetry API call? By default, nothing at all. You need to register providers with the API. And providers, nothing but an implementation. And OpenTelemetry provides the 3 basic providers. But if you like, you can implement it yourself. A tracer provider is used to process traces. It has some basic components, such as samplers to choose whether the record is processed or dropped. Span processors allow you to collect and modify spans. And batch processor batches the spans. And finally, the exporter exports these based on how you configure it to either the OTel collector or your own telemetry pipeline. Similarly, we have a meter provider. The views can be used to aggregate metrics, maybe decorate or add some things on top of the metrics. And the rest of it is pretty much similar. And log provider is also similar. The batch processor batches the logs, and the log exporter can export that. So let's spend a minute to talk about how this context is propagated through a system using OTel. So we mentioned we have a context connecting your metrics, logs, traces. So this context is nothing but the trace ID and span ID. As you can see on the left, let's say if you're making a gRPC call from foo to bar service, what happens internally is the local context is serialized and sent via the headers to the bar service, where it deserializes it and as it adds a new span ID but retains the same trace ID. For intra-service communication, let's say we have an API call that calls a function do work, and you want to instrument do work as a separate span. You will pass the context, which will contain the trace ID, and do a start span operation, which will start a new span. And once the work is done, you can end it. So that's talking about your service, but let's zoom out a bit and see how OpenTelemetry works with other observability technologies. So you have your microservice, your shared infrastructure, your managed DBs, APIs, all using the OTel SDK and API to instrument the code and generate signals such as metrics, logs, traces. You can either send this to a third-party service and process your own metrics, logs, traces, or you can use the OTel collector provided out of the box. The OTel collector finally sends these telemetry data to time series database, column stores, and of course, OpenSearch. If we zoom into the OTel collector, it has three main components. Receivers, it supports various protocols. It has a kind of processor. So you can think of this as a data pipeline, receivers, processors, exporters. And in the processing, you can do filtering, sampling, and enriching data, for example, adding node ID to the logs. Here is a quick recap of what we've seen so far. I think I won't go in the interest of time. So how are we using OpenTelemetry and OpenSearch? So we essentially have a telemetry-otel plugin that we've created. We've imported the OpenTelemetry SDI and APKs. We use this plugin as a lightweight wrapper over the SDK. We support metrics and traces now. The following link will take you to show you how to configure the plugin and get started with OpenTelemetry and OpenSearch. End the talk, I want to talk about instrumentation on the search path and how we use OpenTelemetry. So yeah, I think we're almost out of time, but let me take a minute more. So we essentially create a tracer and metrics registry. We can inject that in transport search action, which is the entry point for search. And create counter methods to create the counter. Let me skip the code examples in the interest of time. And I have a link at the end of the talk if you're interested in the details of the code. I'll skip the key takeaways, but I encourage you to contribute. Here are the open issues in OpenTelemetry and OpenSearch, and we need people to instrument on the search path. Yeah, we just covered the tip of the iceberg today, but feel free to go through these references for further learning. Sorry, Peter. I know it's got.
Thank you so much. Thank you so much. Everyone give him a big round of applause. Siddhant.